Welcome everyone, this is Zanta with Revit Products. Today's video is coming from a request for a previous student. The request is to create a Revit family that is an angled 90-degree plate that looks similar to what this picture is shown here. And they have an initial request of the size being 4 inches by 4 inches by 1/4 inch thick and a length of 1 foot long. And then with 2 holes that allows for 1/2 inch diameter by 4 inch long headed studs. So it's similar to this image here. So let's go ahead and go into the process of how to make this. So the first approach is to make the plate. The second approach is to, the next step would be to create the studs as a separate family and then nest them into this family and then position them accordingly. So I'm going to minimize this view. I'm here in Revit 2019. We'll head over to New Families, and we want to pick from the list, and you want to pick something that makes logical sense. For example, heading over down to Structural. They have Structural Stiffener, which is okay. That should work just fine, and it's just a way for you to categorize how the family is built. So I'm going to click Open. And what you're presented with is a plan view with 2 reference planes. The reference planes have defined origins as checked, which means the intersection is the insertion point of this family. So the first thing you want to really establish is where's the insertion point of this family and how do you want it to grow. If we look at the picture again, if I make the insertion point right here in this lower left corner, then it's going to grow and increase to my right and up. If I pick this corner up here, it's going to grow to my left and down as I increase the size. So it really is a matter of where do you think is the logical position for you to build the family. For the sake of ease, I'm going to put it down here in the middle, so you can see that it'll go right there. I'm in a plan view. And so if I look at the picture one more time, let's head over to that view. Sorry, I closed it. I'm going to treat this view as the front. So I'm standing here looking this way, and this will be my right and this will be my left. I'll head over to the front view so I can see how the reference level is displayed and the reference planes that are displayed as well. I typically take the level and I move it out of the way because usually you'll see a reference plane drawn right here. And it doesn't have a name. This one does. So let's go ahead and give this one a name, and I'm going to call it the bottom. And we need to create the skeletal system that defines the left, the right, the top, and the bottom, as well as the thicknesses of the plate. So I'm going to use the reference plane command. RP is the keyboard shortcut. So I'm going to start slow, but I'm going to build up my speed in a little bit. Okay. So I have one for the left, I have one for the right, I have one for the top. I already have one for the bottom, but I need one for the thickness down here. Now when I'm drawing my planes, I want to try to draw them so the ends kind of line up with each other and keep them somewhat consistent in the length of them once they pass the intersection. You do want to make sure you have clean intersections so it's easier for you to see the intersections and easier for you to draw and snap to those intersections. I'm going to label those reference planes as well. It's important for you to name them. So I'm going to name this the top, and then this is going to be second bottom. You can name them anything you want as long as you understand what you're naming them and how you want to use them. So right and left. And I also need to create reference planes that define the center points of the circles as well for the openings. So if we look at the picture, we've got a couple openings here and here. So I'm going to create a reference plane for the center, and then one over here, and one over here. If you notice, I'm not really worried about the exact placement of those planes right now because I need to use dimensions and some equality conditions to help us place them a little smoother and a little more organized. So we have that for the front. I'm going to head over to the left. So again, if I look at the picture, this is my front and this is my left side, then I should be drawing the vertical and the angle will go out towards my right. So I'll head over to the left elevation. And I don't really like the double clicking sometimes in Revit 2019. It's a little finicky. So I'm going to draw a little piece over here as well. And then we also need a reference plane for the thickness for the part that's going up. And again, draw your reference plane so the ends line up nicely. And you can kind of get a sense of the shape of this L angle right here. Okay? So now that we've done this, we want to head back to the front elevation and we want to start dimensioning and using some of our dimensioning tools to help us understand the overall aspect of it. So we have this, which is going to be the length. We have this one here, which is going to be the height. We're going to have this one here, which is the thickness. We're going to have the dimensions here to here to here that need to be equal because of the opening. We also need the same thing on this side as well. And then if the dimensions seem to be a bit too large, we can change the scale. Let's do 1 inch and it'll be a little smaller, easier to manage. We do want to have a dimension that goes from the left to the center to the right, and that also needs to be equal. That way it grows consistently from the left and the right hand side. Because as it stands now, where is our insertion point? The insertion point is where two reference planes that have defined origins in the properties is checked and where they intersect with each other. So it's right now, right here, the very bottom, which is fine. I can make it the top if I want to. Now that that's created properly, let's head back over to the left elevation, and we need to also create some dimensions here as well. So this is going to be the leg extension as well. This is going to be the thickness. Since we've already dimensioned this in the front view, we don't have to worry about it. And since we dimensioned from here to here as well, we don't have to worry about it. So this is the extension of the leg. So we want to parameterize that. So I'm going to select the dimension and click Create Parameter. And I'm going to call it leg 2. I'm going to leg _ 2. I try not to use spaces in the names because it messes things up when you start doing formulas. And I'm going to make it, for simplicity, a type-based parameter. So that way they all change properly. So if this is leg 2, then if I head over to the, if I go from here to here, that would be leg 1. So let's dimension this from here to here. Now again, I'm going to zoom out. Look, we have a reference level over here. Let's move this reference level out of the way so we don't get confused. And those planes that we drew earlier, let's move them so they make a lot more logical sense. So that plane that represents the top on the left view, it only needs to show about that much. The one that's right here represents the center of the hole, and so we're just going to move this as well and make it a little tighter and cleaner. And then we'll give it a name as well. So I'm going to zoom in a little bit so it's easier to see. And we're going to call it center line hole, something like that. Then we need the dimensioning again for the second leg called leg 1, which is from here to here. And I'm using the keyboard shortcut DI to start the dimension command. So we're going to call this leg _ 1. If we want to, we can make them identical. We can, so that they just use one parameter, and when you change that one parameter, both legs will be the same. But I wasn't sure in this situation if the family needed to be flexed independent of each other. So for now, I'm creating them as separate, just in case that needs to be done. The thickness, based upon the email request, was that it was 1/4 inch thick. Now again, I'm not sure whether that thickness needs to be adjustable or not. So let's, for the sake of simplicity in this video and building the family, we're going to make it 1/4 inch. So if I select the reference plane, I can select the blue text and make it 1/4 inch. And then what I want to do is I want to lock that dimension. And the same thing on this side here, this thickness here, which we dimensioned on the front elevation over here. So if I go in and I select the reference plane again, I can zoom in and select the text and make it 1/4 inch thickness. And then I can select the dimension and lock it, so that will always be a 1/4 inch thick. Since we already dimensioned the elevation on the other view, we don't need to put it over here. We do need this one parameterized because that represents the length, and according to the email, they wanted it 1 foot long for now. So I'm going to put in here length. That way it can be adjustable down the road. All we've done so far is we've built the skeleton system, and they wanted the length to be 1 foot long. So if I select any one of the right or the left reference planes, I can select the text and change that to 1 foot. And everything should be equal. If it doesn't work, what you could do is go back to the Family Types window. You can readjust the size of this, by the way. And let's make the length 1 foot. Now, it didn't work for me earlier because I had my numbers lock turned off accidentally. And so now that I've made the adjustment, it works properly. And we also know that since this is only going to be 4 inch by 4 inch, we can go over here to leg 1 and leg 2 and make it 4 inches. This is what's known as flexing. And basically you're adjusting the design so that it holds the dimensions and it makes sense. So from the front view, I'm not sure what's going on. So let's go to the left view because we also specified the length over here. So let's make this a 1 inch dimension so it's easy to see. We have leg 1 as being 1 foot long, which is from here to here. And did I put in the right dimension? Length 4 inch, 4 inch. And this leg is leg 2, which is I'm sorry, not 4 inches. Oh yes, they wanted 4 inches by 1/4 inch by 1/4 inch. Okay. It looks a little strange because it says leg 1 equals 1 foot, 0 feet dash 4 inches. So if you don't like that, you can change it under Manage tab of the ribbon under Project, under Units. So it looks like we're okay here in this length, but we didn't move and position the center line hole. That's what's happening. So I'm going to move the center line hole back down again. And if we head over to the front elevation, we can see the center line hole is here. We didn't actually specify its position vertically, so we need to strike a dimension from here to here to here and make it equal. And since this is the center line, we just need to move this reference plane close enough so that it only allows for these two inner reference planes to be positioned like this, and we have our intersections. And that's going to signify where the holes are going to go. Okay? Also, the holes, which we have to worry about later, is going to be, as it stood now in the email, they wanted it to be 1/2 inch diameter, but it might change. It might be a bigger diameter, so we may have to parameterize that. So let's worry about the plate for now. If we look at the picture, we know that from Boolean operations, this is a simple extrusion. We can draw a profile that is the top, the right, curves over here, or make it straight, whatever is easy. Bring it across, bring it up, back, and then back up. That's the profile. And it will get extruded this way, to my left, away from my screen, I'm sorry, towards into the screen. And it will be a certain thickness which we can align and lock on both sides. That's going to be the extrusion. We'll worry about the holes in a second. So because of that, I'm going to head back over to the left elevation. I have my framework, which is right here. And we're going to draw using the extrusion command. And you're in sketch mode, so draw the line work that represents the edges of the profile. Now I'm using the pick line method because I can actually choose to lock the magenta line sketches to the reference plane so that they move at the same time. And what that means is that as you adjust the thickness or the length of the legs or the length, the overall length of the ankle, everything will adjust accordingly. So now we just need to clean up our sketch a little bit so you can see what kind of sketch we're going to have at the end of the day. And this is what we have, and it's going to be extruded into the screen away from my face. And when you finish it with the green check mark up here, There's your extrusion. I'm going to switch to shaded view so you can see it. And I'm going to use these arrows to adjust the left side and lock, and the right side and lock. And now we know that all the other planes are aligned and locked properly because we started with that. So if I go to a 3D view, you can see this. And there's your angle. If you need to put in the curve, then just in the draw aspect, use the fillet circle command and specify a radius. For the sake of simplicity and the length of the video, I'm going to keep it simple as an angle. Now heading back to the front elevation, we know we have to have some openings in here, which are going to be nothing more than a void extrusion of a circle. And so I'm going to head over here, back to Create tab, back to Forms, and click Void Extrusion. Use the Circle tool and draw the circle. And they said 1/2 inch in the email, so I'm going to use 1/2 inch. If we don't want to parameterize it, we can then make that temporary dimension permanent. We can select the dimension and we can lock it, so it will always hold at 1/2 inch. For the sake of simplicity, I'm going to lock it. So let's adjust the scale again to make it 6 inches equal to a foot. That way I might be able to get my lock symbol showing a little easier. If it doesn't show you, that's a radius. I'm sorry, not the diameter. So let's make this to be 1/4 inch. That way it's actually 1/2 inch diameter. And then we'll delete this for now. We're then going to head over to the Annotate tab, and I'm going to use the diameter command to pick this circle and place it. And then finish it. I won't parameterize it, I'll just leave it like this. And you can see that the void is cutting through that shape. Now if I head over to the left elevation and I tab into that section, you'll see that the extrusion is pretty long. By default, it's a foot up here in the properties. So we do need to push and pull the edges so that they align and lock to the reference planes that they need to, so that it only cuts what's necessary. Okay? And now that that's finished, we head over to the front elevation. There we go. We're going to take this extrusion and we can mirror it against this plane. And there you have it. Now, to be safe, if I select it and I edit the extrusion, we know it's there. Depending on what you're creating and how you're mirroring content, you may have to align and lock as well. So for the sake of just being safe, I'm going to delete it and draw it again using the drawing tools. And then if I parameterize this as the radius, I'm going to put in here radius of, of hole, then it's at 1/4 inch. And we know that's parameterized so it can be adjusted down the road. So what about the other one that I did? Let's go back to that one, select it, go back to the extrusion. For the sake of consistency, let's delete that dimension and make it a radius dimension. And since we've already parameterized it, we can select that dimension and we can make it the radius of the hole so that they both hold that parameter. Now if you look carefully, the radius parameter was buried inside the sketch of this hole where this one is not. Depending on how the family behaves, it may be stronger or weaker if you put it outside of the sketch or inside of the sketch. I'm going to delete this and go back to this, go back to the extrusion, and then I'm going to dimension it from within the extrusion. And then I'm going to finish the sketch. This one wants to be on the outside, so let's see how it behaves if we hold it like that. We might get some weird hiccups and issues, but for now that's fine. If anything, we can always go back to this particular one, edit the extrusion, delete that dimension, finish it, and then put the dimension on the outside of here as well. We'll save it in a second. Selecting the dimension, again giving it the same parameter, you'll get it. Done. Now, let's look at it in 3D. And we're going to switch this, instead of 1/8 of an inch, we're going to switch it to 6 inches equal to a foot. Zoom in here a little bit, and we can see what we have. Now this is at the point where we've done quite a bit of work already, and it's only been a few minutes, 20 minutes. So we need to save this family so we don't lose anything. So we'll save this family, and I'll put it under my temp folder, and I'll call it angled plate family. Now we have to flex it because we have added more content, so we want to make sure it's flexing properly. Let's change the radius of the hole to 1 inch, which means the diameter should be 2 inches and it should get bigger. And if it doesn't, that means something's not right. As you can see here, the constraint's not holding, which means that the radius parameter we put in there, when we put it in there, which is outside the sketch, is causing conflict. So we're going to remove the constraints, go back to the front view, and we're going to delete this dimension and delete this dimension. We'll then go back into the sketch and edit the extrusion, and we'll parameterize it here and finish it. Now if we take this and we parameterize just this one for testing purposes, it still says constraints are not satisfied, so something else is causing it to break, and so we'll have to dig into that later. For now, I'm not going to parameterize it. I'll just leave it as a 1/4 inch for the sake of the video and the timing. Now that that's finished, let's go ahead and let's delete that radius hole dimension. We don't need it anymore. And again, verify if we make this 2 feet, we make this 6 inches, we make this one 8 inches. Does it flex properly? And it does. Okay, if we look at this in 3D, we should see that it flexed properly, and this is longer than this because our dimensions are different. So this is how you make a angled plate family. Now, how do you make the bolts to fit and be placed inside here so that it's placed properly and it functions the same way? For now, I'm going to save the work, and I need to start a new family. So we're going to say File, New, Family. And again, we want to pick something that makes sense. Say structural stiffener is fine. It could be a generic model at this point. It doesn't really matter. It just depends on if you want to schedule that kind of data or not. So I'm going to click Open. And again, we have the reference planes that define in plan the insertion point. And then if we go to the front elevation, we have a reference plane. So this is where it gets critical from the standpoint of orientation. We drew the angled plate such that this is the front. So when we are inserting the object, we want the front, the head of the bolt, to be in the same kind of orientation. So we work from the front elevation. We can draw a bolt here as well. Okay? So for the sake of simplicity, what we're going to do is we're going to head over to the Create tab and do the extrusion command and use a circle and then draw our diameter and go from there. Now, we're going to select this and parameterize this as well, and we're going to select the dimension and give it a radius of hole. And before we even do anything else and finish the sketch, let's switch it so it's easier to see the scale. Go into the Family Types window and change the dimension from 1 inch to say 1/4 inch, and see if it behaves properly. And it does. Okay? So we're good there. We'll finish it. We know this is the front elevation, so what we need to do is you need to look at the left or the right elevation so that we can define how deep the bolt goes into the screen. In other words, the length of the bolt. So I'm going to head over to the left side, and this is this plane that we're drawing is working with is front center. So I'll just create a reference plane over here. Oops, my bad, my apologies. Not straight here. And we'll name this one back reference plane. And then we can take and dimension from that plane to this plane, selecting that dimension, and then we can go ahead and give it a length, say bolt. Oops, sorry, bolt underscore length. This way, it's easy for us to control the length of the bolt independent of anything else. Don't forget, you want to align and lock the ends of the bolt so that they align and lock correctly. And then as for the head of the bolt, same kind of approach. We're going to create a reference plane for how deep the head of the bolt is going to be. And for the sake of simplicity, we're going to make it a certain thickness and lock it. So right now it's 1 7/32. Let's go ahead and change it to 1.5 inch thick bolt. Oops, I forgot the space. Now that we've done that, we can take that dimension and we can lock it. So that way it knows it's that size. Heading back to the front elevation, we can then go in and draw another extrusion. And we're going to start with let's do this one. Inscribed polygon or circumscribed polygon. Let's do this one. And we'll say 6-sided is fine. We're going to place that point here. And then we're going to, let's make it, actually, let's use the other one, this one, circumscribed about the polygon. That way it's on the outside. And we click here. Actually, the bolt needs to be much thicker. So it needs to be roughly this much thicker. And we're going to finish the sketch. There's our bolt. Heading back over to the left elevation, we can then take that bolt and we can move the planes so that they align and lock to the other planes that we created initially. And then if we look at this in 3D, it looks like a bolt. Okay? And then we're going to go ahead and save the file. Save as a family. We're going to call it bolt. And then we're going to load this family into the angle plate family. In other words, nest it. So clicking load into project allows me to put it into this particular one. I'm in a plan view right now, and you can see it is oriented properly. So I'm just going to place it like this. Heading over to the front elevation, you can see that bolt is placed right there. Aligning and locking to this plane, the center of the bolt, will give us the orientation that we need, and same thing horizontally. So let's move this out of the way so there's no confusion. I'm picking the wrong plane. And if you notice, I can't hit the horizontal plane of this bolt, so that means that something in the bolt family is off. So editing the family, we can get back to this one here, and it says is reference center front back defines an origin. Heading over to the front elevation, this one is not a reference. There we go in the properties. So we need to switch this to be a strong reference. That way it can see it and we can use the align command. Saving it and then loading it back into the project and overriding what we have, we can then align and lock accordingly. See? And just to be safe, I'm going to pick this and pick this vertical. I don't need to. It is aligned and locked. So we have it lined this way, but what about from the left elevation? Heading to the left elevation, you can see it's placed here. We're going to align to that plane, that edge, and lock it. As for the length of the bolt, it said it needed to be 4 inches long. So did we parameterize the length? If I go back to editing the family, and we go to the left elevation where we were, for this, did we define this? Yes, we defined the bolt length. So let's go into the family types window and make the bolt length the 4 inches that was requested. Like so. Save the file, load it back into the project, and overwrite what we have. And there you go. If we look at this in 3D, it looks like this. If you need to, you can actually join geometry of the head and the actual long portion of the bolt, so it looks like a single unit. I'm not going to bother with it right now. Heading over to the front elevation, we can then take this object and we can mirror it against this plane. There you go. Now we do need to align and lock here as well, because if we don't, it doesn't stay put. And lock. Okay? And then little things that you might want to also look at the horizontal reference plane that we drew for the center line of the bolt. Because we adjusted the length of the angle plate, the end of the reference planes are not going as far as I want them to go. So I'm just going to stretch them out a little bit like this. And 6 inches is a little too big of a scale. And there you go. There we have it. We save the work, look at it in 3D. We'll close all the other inactive views. And then lastly, we want to flex to ensure that it's functioning properly. So let's make the length 3 feet. And let's make the leg 1 foot and 1 foot and apply. And does it adjust? Yes, it does. So in regards to the picture, the only thing left is the 2 holes that are down here. You would use the exact same procedure for drawing the holes down here and aligning and locking and then placing the bolt accordingly. So this was a video on how to create an angled plate with a couple bolts as per the request of a user, and I hope this helps. Thank you very much for watching.